Hello guys, myself Ajad and welcome to Staad Pro tutorial, and today's tutorial is how to analyze this wind load on RCC building. So this is the problem. You can see this is the top view of the RCC building. This is the multi-story building and you can see wind load, and you can also see primary load combination. So initially you have to go Staad Pro. So just wait and then go to new project and then space as a 3D and give some name and meter and kilonewton, and then next and then add beam and then finished. And so from this problem you can see this is a length and this is a length and this is the width. Okay, so 4 meter and also 4 meter, total 20 meter. So length is 20 meter and height is 20 meter, sorry, width is 20 meter. So go to geometry and run structure wizard and frame model and wave frame in double click, and length is 20 meter, base is 5 and height is 15, this is 5 and width is 20, base is also 5. So apply, this is the building, and go to transfer and yes, and then OK, and switch off the grid and go to properties. So go to general and define properties, go to rectangle and size is 0.4 into 0.3 and then add and then close, and then select all the structure and then assign to selected view and then assign. So this is the assign of the properties, and you can see 3D view. This is the building of the 3D view and assign this. So we have to go to support. To go to support and create support. Support is fixer support. So go to fixer support and then add and then click support and go to front view and then select node and you can check isometric view and then assign to selected node and then assign. So our support is also ready. So we have to go load. Go to load combination and load capacitors and then go to add and then live load and dead load and wind load. So dead load, loading type will be dead and then add. Live load, loading type will be live and add. Okay, and then wind load is x positive, x negative and z positive and z negative. So wind load at x positive. Okay, copy this and then loading type will be wind and then add and then wind load at x negative. So x negative, loading type will be wind and then add, and then loading type will be wind and wind load at z positive and then add, and wind load at z negative and then add and then close. So go to dead load, and dead load is in this problem self weight wall load 6 kN per meter and slab load 4 kN per meter square. So go to dead load, then add, then self weight add member load -6 as a download is kN per meter, and floor load, that is slab load. Slab load is 4 kN per meter. -4. Range is 3 to up to 15, and then global y direction, and then add, and then close. So dead load is complete. And live load you can see 2 kN per meter square. So live load, go to, and then add, and then floor load 2 kN per meter square. Range is 3 to 15, and then add, and then close. So dead load, live load complete. And go to wind load, and then add, and then wind load. You can see wind definition is required in order to assign a wind load. So you can't put it, so you have to go to definition, and then wind definition, and then add, and then wind 1, and then close, and then type wind 1, and then add. Intensity is 1.5 as per ice code, 1.5, and height is up to 15, and then custom, and then calculate as per AEC 2010 category. You can see building structure, no, and then okay, and then add, and then factor is 1, then close. So firstly we have to assign self weight and wall load. Show self weight, click self weight, and enter the structure, select all, and assign to selected beam, and then assign. Then yes, and wall load is beam load. It will be X and Z direction. So go to select, and beam parallel to X direction, and beam parallel to Z direction. So beam parallel to X direction, and select, and beam parallel to Z direction. Then assign to selected beam, and then assign, and then yes. You can see slab load, and you can also see live load. You have to edit this as a edit, and -2, and do change, and then close. So your live load is 2 kN per meter as a downward direction. So you have to assign wind load. You have to initially assign intensity. So click here intensity, and select node cursor, and select all node, and then assign to selected node, and then assign, then yes, then go to wind load. So wind load at X positive, and then add, and then wind load, and then wind load force, and factor is 1, and then add, and then close, and X negative, and then add, and then wind load, and wind load force, and this is the minus. So minus, and then add, and then close, and then X positive and X negative, and then factor is, we have to select Z positive. So Z positive, and then add. So go to wind load, and Z wind load force, and factor is 1, and then add, then add, okay, and then close, and then win load at negative, z negative, so add, and then win load, and then z unit force, and factor will be -1, and then add and close. So you can see win load at x positive, x negative, x positive, scale the load x negative, and you can see z positive and z negative. So we have to create combination. So combination. So go to load case details and add, then define combination, and 5 type of combination. You can see on this problem, you can see 5 type of combination. So we have to create combination, 5 type of combination. So 1.5 factor, dead load plus live load, dead load plus live load, factor is 1.5. Copy this, and dead load plus live load, and then click here and then add. And second combination is dead load plus win load. So dead load plus win load. So win load at x positive or z positive. So win load at x positive, and then 1.5 factor dead load plus x positive win load, and then click here and then add. And then third combination is 1.5 factor dead load minus win load. So dead load plus win load at negative direction. So factor is 1.5, dead load x negative or x z negative as your wish. So I can choose z negative, x negative, okay. So here and select here and then add. So next combination is 1.2 factor and win load plus dead load plus live load plus win load. So dead load plus dead load plus live load plus win load at positive x direction, positive x direction or positive z direction. So z positive as you wish, and copy this for the next combination. And factor is 1.2 and dead load, live load and x positive win load, and then click here and then add. So next combination is 1.2, next combination 1.2 factor dead load plus live load minus win load, that is win load at negative direction, negative or x negative. Factor is 1.2 dead load, live load and win load at z negative, then click here and then add and then close. So our combination is ready. You can see your combination, you can see also. So we have to design this. So go to design tab and define parameter and FC, go to design tab and material is concrete and define parameter, and FC is for M30 30,000 km per meter square, 30,000, and then add an FOMN AF415 for AF415 415 000 kilonewton per meter square, then add. And FY ACC also 415 000 kilonewton per meter square, then add, and then close. You can see here, and you have to go command region beam, then add region column, and then add, then take off, then add, and then close. So we have to assign all these commands. So click here, and then select, enter the all structure, then assign, then yes. Then here also assign this, here also, and here also assign, and then design beam. So beam is only x and z direction, not a column. Okay, so select beam parallel to x direction and select beam parallel to z direction. Okay, and then assign this beam, and then lastly column. So click here and go to select and beam parallel to y direction, and then assign this, then yes, then analysis and print, and then add, and then close, then analyze, then run analysis, and then save, and then just wait. And go to stain modeling mode and done. Then go to select and by specification, and all failed beam, so no beam failed for the steel, aluminum, steel. Okay, so go to post processing, and then okay, and then you can see your displacement for the building. You can see various type of load combination: load, dead load, live load, as you use various type of load. You can check dead load, live load, etc. Various type, different type of load. Okay, you can check wind load. You can check also bending. So you can see bending moment, also shear force. Also you can check bending shear force, also axial forces, etc. You can also check reaction. Reaction is here and here. You can also animation this section, displacement, and then okay. You can check various type of load. You can check dead load, live load, and wind load, x positive, or wind load x negative, or wind load x positive, z positive, z negative, and load combination, various type of load combination. So escape here. So this is the end of the tutorial. If you have any problem in this tutorial, please comment. And next tutorial is how to analyze earthquake load on RCC building. So please subscribe for more video. Thank you for watching.